form the same way. Cold, dry air moving in from the west, warm, moist air coming in from the south. The combination of these causes the air to rotate in the mid-levels. Eventually, what will happen is this rotating air will turn from a horizontal direction to a vertical direction.
Here we have a tornado tube connecting these bottles. As you can see, you turn it upside down, not much happens. You spin it though, and you get this lovely vortex created. You see the water goes down, the air comes up.
Warm, moist air flows into a storm. It gets pushed up and twisted by upper-level winds. As this rotating column of air gathers force, conditions are ripe for a collision below. When rain-cooled downdrafts hit warm air near the ground, a low-hanging revolving cloud forms beneath the cell. A tornado is imminent.
My question is, how do tornadoes start?
A thunderstorm begins when warm, humid air near the ground becomes unstable and rises, condensing into water drops to form a cloud. This rotating air sometimes extends down to the ground as a tornado, picking up dust and making the funnel visible.
What it has to do is this. During storms, you get very erratic winds, erratic shifting winds, what we call wind shear. Wind shear is when the wind, one elevation can be blowing one way, another elevation can be blowing another way. And that's what's happening right here. We get a rolling motion of the wind, a rotor, if you will, along the ground. But near thunderstorms, everything is being sucked up.
Tornadoes occur on every continent except Antarctica, but more form over the central United States than anywhere else in a zone called Tornado Alley. That's because conditions in the alley are ideal for creating tornadoes. Warm, humid air low to the ground moves north from the Gulf of Mexico and collides with cool, dry air high above the ground rolling in from the Rocky Mountains. The collision of air masses creates a supercell, a massive thunderstorm that has a strong rotating updraft of air.
Go ahead and turn over like this and spin. As you spin, you get this vortex, which is kind of nice. Good, and you can stop spinning. All right, there you go. See, and there's your little vortex. This one here is different, which is kind of nice because the kids can see water down and air up. As you turn this one upside down, there's a small amount of colored oil in this one. So watch what happens, and up close as you see this, watch this. You now can define just
I love that one.
the
That's
vortex.
lamp oil, right?
Isn't it? Yeah, it's just amazing. Isn't that kind of fun?
The grandkids love that one.
As we're talking about, and if I spin the table like this, watch what happens. You get that spinning force, nothing much happens.
Right.
Right? All right, so let me put this out. And what I want you to know is just the spinning isn't the tornado.
Okay.
You've got to have this hot air, as Marty would tell you, or anybody in the newsroom. The hot air rises and it collides with that cold air front that comes in. It's going to be good. As we spin it now, the hot air will rise, but you're actually going to catch the air here with the screen.
I see. Right.
And so now watch what we get when you spin. Watch what you get here. You get this fire vortex.
How
Isn't that just
about
amazing?
That is
so
remarkable.
now it's not just a weather phenomenon. Now when forest fires take place, now they have to worry about those winds whipping through the trees that create a fire tornado.
Oh my God! It's a tornado!
And it's coming this way! We gotta run! Hang on, guys. It might just be the Tasmanian devil.